Everybody. So new topic. We're going to talk about the node voltage method for analyzing circuits. But let me start by going over some vocabulary and terminology. So I want to focus on these four: nodes, essential nodes, loops, and meshes. So let's start with this, a loop and the mesh. So a loop is a path where you start at a node, like say this one, and you go around the path and you end up at the same node. Right? So that's a loop. Or let's say you start at B, you're going to go around this way and end up here. So that's a loop. So it's like you could play like a nerdy game with your friends. Like, how many loops are in this circuit? 1, 2, 3, 4, 5, 6. Like, you can, there's a bunch of them, right? I'm not concerned with that so much. What I care about is a mesh. So it's a loop that does not contain other loops. So like this one is a loop, but it's not a mesh because it contains other loops. So meshes would be here, 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 and here. And we're going to need that for a method we'll talk about in another video called the mesh current method. For now, let's focus on nodes. So a node is where two or more circuit elements join. So like this, all the ones with letters, these are all nodes. Let me point out that these are the same, and for G, these are the same. Okay, but now let's focus our attention on essential nodes, where there are 3 or more elements connected. So for example, node A is not, B, yes, C, yes, D, no, right? D is connecting only 2, E, yes, F, no, G, yes. So let me get rid of the ones that are not essential. So this circuit has 4 essential nodes. And my claim is, if you can calculate the voltages at the essential nodes, you can solve for everything in the circuit, the voltage across everything, the current everywhere. Okay, and then for voltage, it depends on what your reference is. So for example, like let's go to a kind of physical example. If I ask you the question, what's the height of the ball? Like this. Or is it? Because what if the person is standing on a chair? Then is the height of the ball here? And what if the person standing on a chair is on the 2nd story of a building? So is the height of the ball with respect to the 1st floor of the building? Is it with respect to the roof of the building? So when you say the height of the ball, with respect to what reference? So same story with a circuit. Say, what's the voltage at B with respect to where? So to indicate a reference, so this mechanical system, like you can say, this is my datum, that's my reference height. With a circuit, you indicate some reference like this. You draw it kind of like a triangle. Or like if I pick my reference at C or at E or at B, it's just kind of like downward pointing triangle. You would just pick one, not all 4. I'm just showing how you would draw them. And let's say I'll just pick one at G. If I know the voltage, let me just make up numbers. Let's say the voltage at B with respect to my reference is 12 volts. At C, 8. At E, 6. Okay, so if I know those three with respect to my reference at G, what's the voltage for across R5? 6 volts. How about from here to here? 2 volts. Here to here, 6. Here to here, 12. Let's say this is a 5-volt source. See the plus sign here? That means this is higher than this. That's maybe physically impossible. Let me make it 2 volts. Right, so this is higher than C by 2 volts. So over here would be 10 volts. So then here to here has got to be 2. And then let's say this voltage source is 3 volts. So see the plus here and the minus here. That means this is 3 volts less than here. So it would be 5 volts over here. So then here to here, 5. Okay. So now let's get into how do you do the node voltage method. It's simple but powerful. Okay, so consider this circuit. How many nodes? Here. But that's not essential. It only has 2. This is essential. I'll just name it node A. This is, I'll name it node B. Over here, yes, I'll call it node C. Now, where do you want to pick your reference? Any of the 3 is totally fine. There's no wrong choice. It is clever computationally to pick your reference where there are the most elements connected to it. So node A has 3, B has 3, C has 1, 2, 3, 4. So I'm going to pick my reference at C. Okay, so now what you do is write KCL at the essential nodes, not at the reference one. So just these two. So KCL, and you decide if you want to say current going in is positive or current going out is positive. There's no wrong choice. You just pick one and stick with it. So let's say I'm going to compute the current going out of node A. So this is KCL. Okay, so I'll call this I1, I2, I3. So KCL is I1 plus I2 plus I3 equals 0. So now let's combine that with Ohm's law. What is I1? V over R, VA minus the voltage over here, divided by 1 ohm. What's the voltage over here? It is 10 volts more than it is here. And here is VC, right here is VC. The voltage at node C, which I called my reference, which means it's 0. So this side is 10 volts higher. So right here is actually 10 volts. So Ohm's law is VA minus 10 over 1 ohm. Right, that's I1. Okay, now I2, Ohm's law would be VA minus VB over 2 ohms. Right, the voltage at A minus the voltage at B divided by 2 ohms. Okay, now I3, I drew my arrow going out, so it's VA minus VC over 5 ohms. Equals 0. And note that since I called VC node C my reference, VC is actually 0. Okay, now that's KCL at node A. Now let's write KCL at node B. So I'm going to stick with the going out is positive. So going out of node B is this way, and this, see this 2 amp is coming this way. I'll call this I4 and I5. Okay, so KCL out of node B. So let's start with I4. Well, it'll be I4 plus I5. And since this one is going into the node, negative equals 0. So that's KCL. Okay, what is I4? This voltage minus this voltage over 2. So the voltage at node B minus the voltage at node A over 2 ohms. Okay, how about I5? The voltage here minus the voltage here over 10. And again, the voltage here is 0 because that's my reference. And the minus 2. Okay, so if you look at it, let's figure out what is known and what is unknown. I don't know these two node voltages. So we have 2 equations, 2 unknowns, which you can solve. Right, so just, if you want to watch me do the math, or I'll let you solve it. Let's see. How about I'll multiply, I want to get rid of that denominator, so I'll multiply everything by 10. So times 10 times 10 and times 10. Okay, let me gather terms here. So I got 10 and 5 and 2, so 17. And then this and this. I'll move that on the other side. Okay, now this equation, I'll, let's see, common factor, also times 10. So times 10. Okay, and then I'll gather this and this, so that's 6. Let me write this over here next to the other one. Okay, so here you got 2 equations, 2 unknowns. You can just solve by substitution. If you want to use the computer, you can write it as a matrix like this. Right, and if this is matrix A, this is vector X, this is vector B. Right, to solve this, for X, the inverse of A times B. And the computer can do that for you, and the solution will be the 2 node voltages. Okay, so hope that makes sense. Give this a try, and then I'll see you on the next video.